Hello everyone. Today we will discuss about refraction of the light. So just like light shows reflection whenever light is incident on a opaque medium, then light is bounced back to the same medium because light is not able to enter the other medium, right? So from an opaque surface, light get reflected back and it follows rules called as rules of reflection, and we did there discussed the reflection of different kinds, and then we have discussed the reflection from plane or from the spherical reflecting surfaces, or we can say spherical mirrors, concave and convex. And so is the case with the transparent. If the medium is not opaque, it is a transparent medium. That is the medium through which the light can travel, right? So in that case, the light follows the phenomena, or we can say process, what we call as refraction. So what is refraction? It is the phenomena which takes place whenever light enters from one kind of medium to other kind of medium. So what happens in this phenomena? In this phenomena, the change in the path of the light ray takes place as it travels from one medium to another, right? So refraction, it is nothing but the change in the path of the light. Even if the path of the light is not changed, which is not possible if light is incident obliquely. So even if path of the light is not changed, still there is refraction in the, we can say, light. So what does refraction mean? Is simply we understand it as the phenomena of the change in the path of the light as light travels from one medium to another. So how these two mediums are different from one another? In what term they are different? So they are different in their properties by which the direction or change in the path of the light ray depends in that particular medium. So it can also be defined as the phenomena of change in the speed of the light from one medium to another. Actually, what happens whenever light enters from one medium to another medium, the properties of the light changes. The properties just like its speed and its wavelength. So with the change in these properties, the refraction in the light takes place, right? So this is about the basic understanding of refraction of the light. So just as we have discussed in case of reflection, light follows the reflection only by undergoing few or we can say by following some rules called as the laws of reflection. So is the case here. Whenever light ray undergoes refraction, means change in the path of the light whenever it goes from one medium to a different medium, the rules are called as here the laws of refraction. The very first law is that the incident ray, the normal to the refracting surface at the point of incidence, and the refracted ray all lie in the same plane. This rule is very similar to the one rule given in the law of reflection. Okay, so let us not just confuse it. So first law is very simple, that if let us take this slab to be a different medium, and outside this slab we have some other medium, right? So for the sake of convenience, we are taking that this medium, outside this medium, it is the rarer medium and it is the denser medium. We will understand what rarer medium is and what denser medium is. So whenever light ray comes from a rarer medium and is incident obliquely on the surface by making some angle with the normal at the surface. So this surface is called as the interface. So this surface, it is called as the interface which separates the two media, right? So whenever light ray is incident obliquely by making some angle with the normal drawn at that point where this light will be incident, it will change its path. It will bend just like this. So it will make a different angle. So this light ray, it is called as the refracted light ray. It makes some angle with the normal, same normal, and this angle will be called as angle of refraction. This will be different from the angle of incidence, right? So this is happening here. So this is incident ray, this is the normal, and this is the refracted light ray. So the very first rule is about these three terms. The incident ray, the normal at the point of incidence where the incident ray is made to meet the surface of the other medium. And the third thing is this refracted light ray. All these three will lie in the same plane, right? So this is the first law. And the second law is that the ratio of the sine of angle of incidence to the sine of angle of refraction. Sine is nothing but the trigonometric function. So the ratio of sine of angle of incidence to the sine of angle of refraction, it is always a constant. So this ratio always remain constant. So this ratio always remain constant for all angle of incidences and for all corresponding angles of the refraction. But these remains constants only for the given wavelength of the light and for the given pair of the medium. If we change the wavelength of the light, for example, we use red instead of blue, then this ratio will again change, right? Then it will change. Or if we keep the light of the same wavelength but we change the pair of the medium we are using, right? Then again this ratio will be different at same angle of incidence, right? So this ratio will be different. So this ratio will hold for given pair of the media and for the given wavelength of the light, right? So how we define second law correctly? We can define it by, for a given pair of the media, for given set of the two media which are involved in the refraction of the light, and for the light of given wavelengths, right? So particular, we are using a light of particular wavelength. So if these things remain same, then the ratio of sine of angle of incidence to the sine of angle of refraction, this always remain constant. And this second law, it is also called as the Snell's law. So we can put this ratio in this way. So sine of angle of incidence divided by sine of angle of refraction, it is equal to constant. It is constant. So this constant here, it is represented by mu. In some books it is written with small n, so there is no difference for the notation. The physical meaning should be clear. Okay, so this constant here, it is called as the refractive index of the medium with respect to the first medium. Second, this is nothing but the refractive index of the second medium with respect to the first medium. Here first medium is the medium from which the light ray was coming, and second medium is the one in which the light ray is entering, right? So this will be the refractive index of this medium, second medium, with respect to the first medium. So in this constant, it is nothing but the, for given pair of the media, it is nothing but the relative refractive index. However, we call it just refractive index of the medium if the first medium from which the light ray is coming, it is a vacuum or air. So whenever light ray goes from one kind of medium to other kind of medium, depending upon the nature of the medium to change the properties of the light ray in terms of its speed or in terms of the wavelength. It always follows these two laws, right? Now we can talk about few important terms associated with the refraction of the light. The very first thing is mu, means the refractive index of the medium. So the refractive index of the optically rarer medium, here we are talking about optics, means the study of the lights. So here we are taking two media, one is the rarer medium and other one is the denser medium. So which one is called as the rarer medium and which one is called as the denser medium? So the medium of lower refractive index, it is called as the rarer medium. So refractive index of the optically rarer medium is lower. So if there is a rarer medium called rarer medium, it means its refractive index is comparatively low. So whether it is rarer medium or denser medium, it is known by the refractive comparison of its refractive index with the other medium. So this point you must understand, that refractive index of optically rarer medium is lower in comparison to the other medium, and the refractive index of a denser medium is higher, right? Second point to understand is that refractive index of denser medium with respect to the rarer medium is more than 1, because the refractive index for the vacuum or for the air is remains very close to 1, and for all other media other than the vacuum or we can say air, the refractive index is higher. So if this is the case, the mu means the refractive index of the denser medium in comparison means with respect to the rarer medium, it is more than 1, right? So refractive index of denser medium with respect to the rarer medium, it means we are comparing the refractive index of a denser medium with respect to the refractive index of the rarer medium. So as I have already said, the rarer medium has the refractive index 1, and all other mediums, not just a rarer medium but air, right? So the air has refractive index equal to 1, or vacuum also has the refractive index equal to 1, and all other medium has comparatively higher refractive indices of their own, right? Not in comparison but of their own. So what happens here, one which is having, according to this first rule, one having the lower refractive index, it is said to be a rarer medium. So whenever we are comparing the refractive index of denser medium with respect to rarer medium, means we are putting the refractive index of denser medium in the numerator and the refractive index of rarer medium in the denominator, just like this. So the refractive index of denser medium divided by refractive index of the rarer medium means the refractive index of denser medium in comparison to refractive index of the rarer medium, it will be more than 1, because denser medium will have its higher refractive index. And for symbolically we write it as mu dr. D is kept in the subscript and superscript, and R is kept at the subscript. Remember this thing, okay? And conversely, the refractive index of rarer medium with respect to the denser medium. Now we are keeping the refractive index of rarer medium in the numerator and the refractive index of denser medium in the denominator. Then this ratio will be less than 1 according to simple mathematics, and the symbol will be changed to this. So according to these notations, we can see that the refractive index of denser medium with respect to rarer medium, it will be reciprocal to the refractive index of rarer medium with respect to the denser medium, right? So these are the few things which one must understand. Another point to look here is that in case of refraction, the velocity and the wavelength of the light changes. So both these properties of the light changes whenever medium changes, right? So in refraction, another point to understand or know here is that in refraction the frequency and the phase of the light does not change. So these do not change. So these two things related with the light does not change. The phase and the frequency, they remains unchanged. So for the refractive index, we have this relationship here which one must remember while taking the case of refraction. So this is nothing but the refractive index of medium with respect to A stands for air. Here we are comparing the refractive index of medium, any medium other than the air, glass, water, whatever it is, and A is here air. So we are finding the relative refractive index of medium with respect to air, or we simply call it the refractive index of that particular medium, because the refractive index of the air is 1. So we simply call it to be the refractive index of that particular medium itself. However, we can also call it to be the relative refractive index. Actually, there are two terms: absolute refractive index, the refractive index of any medium, right, of its own, and the relative refractive index, the refractive index of one medium whenever it is looked in comparison with the air or any other medium. So here we are taking that air is the first medium and this second medium is M. So this is the relative refractive index of medium M with respect to air, or it is also called as simply the refractive index of medium M. So we need not to write it just like the standard notation. We can also write it just as mu, just as we are writing here. So the refractive index of the medium, it is given by the ratio of the light in air medium to the ratio of the to the speed, it is the ratio of the speed of the light in air medium to the speed of the light in that particular medium of which the refractive index is getting calculated. So it is this ratio, the speed of the light in air to the speed of the light in medium, it is called as the refractive index of that medium, right? So because the speed of the light changes, the speed of the light decreases in the medium other than the air. So this ratio, or we can say this relationship, will give us the relationship between speed of the light in that particular medium and its refractive index, right? And there is also another relationship which we can write here about the refraction. It is that refractive index of that medium can also be calculated as the wavelength of the light, ratio of the wavelength of the light in air to the wavelength of the light in that medium for which the refractive index is being calculated. So these relationship you must hold, understand clearly. Okay. So for a medium having higher refractive index, the light will travel slower in that medium, right? And to counter for that lesser speed of the light has to follow the change in the path of the light itself, right, which is called as the refraction. So why does the refraction actually happens? Because light wants to take the path for which the time is short. The light wants to take the path which along which the time taken by the light will be short, so for the lower speed of the light. So that is the reason here. Okay, so refraction takes place because light always wants to take the path which takes the least time. So if the speed of the light is reduced in a medium of higher refractive index, that means the light will take a different path than it was taking earlier. It will just change its path in order to move along the path of the least time. So this is the reason for the refraction of the light. This can also be understood by the Fermat's principle. Okay. Now we move to the next important topic of principle of reversibility of the light. So these are the important articles to understand. There is no issue there. So here we are taking a rarer medium A and a denser medium B. So rarer medium having A, it is the medium of lower refractive index, and denser medium is it is having the higher refractive index in comparison to that of the rarer medium. Okay, so this is what we already understand. So from here we take that the light ray is coming from a rarer medium, incident at the interface separating the two media, and at the interface the light ray changes its path along this direction because of the refractive index of the second medium B, which is the denser medium, right? So the light ray will bend towards the normal if it is the light ray is coming from rarer to denser medium, and because the light ray will get slower. So this will only the path for which the light ray will take less time. Conversely, if the light ray is traveling from denser medium to rarer medium, that means the speed of the light in denser medium is less, the speed of the light in rarer medium will be higher. So the light can take a longer path for the same time. So it is the same reason here. Okay. So in that case the light ray will bend away from the normal. So for the light ray traveling from rarer medium to denser medium, the light ray will bend towards the normal, right? And conversely, if the light ray is traveling from denser medium and entering a rarer medium or emerging in a rarer medium, light ray will bend away from the normal. Okay. So here light ray is incident on this interface separating the two media A and B. the light ray will bend towards the normal because light ray is entering a denser medium, right? Whenever this light is getting reflected back along its own direction, which is possible whenever this light, refracted light ray, is incident at perpendicular to the mirror, surface of the mirror. So we are putting a mirror here, plane mirror here. So we are making the light, this refracted light ray, to fall normally on this mirror, so that angle of incidence is 0. So therefore, according to laws of reflection, the angle of reflection will also be 0. So light ray will get retraced along its own path. So the light ray will just follow its own path, and now the light ray is traveling in reverse direction. So this angle R will be the angle of incidence, and this angle I will be the angle of refraction for this reflected light ray. So this light ray is traveling now from denser medium and emerging in a rarer medium. So this will bend away from the normal along the same path. So what principle of reversibility of light says? To summarize that, we just write these two relationships. So in first case, whenever light goes from medium A to medium B, so the refractive index of B with respect to A, it is called as sine of angle of incidence to the sine of angle of refraction, according to the Snell's law, as we have discussed during this. Okay, and in reverse direction, whenever this light is just reflected back, it just retraces its own path, or we can say the light just travels back along its own path from which it was coming. So for that, it is now the light ray coming from the denser medium and emerging in a rarer medium. So the second medium is now rarer medium. So that is why we are writing it refractive index of medium A, which is the second medium, with respect to the refractive index of medium B, which is the first medium. This is equal to sine of angle of incidence. Here sine of angle of incidence is R now, to the sine of angle of refraction, which is I here, right? So these two are just converse of each other. So if we multiply, we have already discussed about these two here in these two expressions, right? So from here, whenever we multiply these two, on the left hand side we get mu BA multiplied by mu AB. On the right hand side, I cancels out with I in the denominator, and R, sine R, cancels out with sine R here. So on the right hand side we have 1. So that means the refractive index of B with respect to A, it is equal to the reciprocal of refractive index of medium A with respect to B. So what does it mean? It simply means that if a light ray after suffering a number of reflections or refraction has its path reversed at any stage, if at any stage its path is just reflected back, or we can say reversed, it just travels back to the source, from where the light was actually coming originally. Okay, so it travels back to the source along the same path in opposite direction. So this is the principle of reversibility of the light. So a natural consequence of principle of reversibility is that the image and object positions can be interchanged. What does it mean? It simply means that where the image is placed, we can take that we can place the object at the position of the image and image at the position of the object. We will get the same result. So these positions are called as conjugate positions. Okay, so this relationship is very important, which comes from the principle of reversibility of the light. So that is all for now. Thank you.